the need to make certain assumptions that other methods may apply is reduced, and thus the number of false positives and false negatives are also reduced. Reviewers can also draw upon their personal experiences and expertise in certain technologies that may be difficult for automated methods to emulate. Essentially, the security code review process will be able to identify certain vulnerabilities that other assessment methods cannot. Another advantage of security code reviews is that assessments can be performed in a more context-aware fashion than that which is possible with machine-based methods. Human reviewers have the distinct advantage in that they are able to interact with the architects and developers of an application. Through this interaction, they can gain a better understanding of the application, such as the intent of the application, valid user scenarios and dependencies, and make more meaningful reports and recommendations. Having this understanding allows reviewers to better determine critical components of the application and focus efforts on those areas rather than on less critical components. In addition to the advantages of employing a security code review process, there are certain disadvantages of which you should be aware. One key limitation of the security code review process is that it is a manually intensive process. Human error and fatigue may become factors when reviewing application code, especially when performing a security code review for large applications. Furthermore, with modern-day applications easily exceeding hundreds of thousands and sometimes millions of lines of code, completing a security code review may require a large amount of time and effort, therefore becoming a very expensive proposition. The final notable limitation regarding the security code review process is that the quality of the review is highly dependent upon the skill level and expertise of the reviewer. With code analysis tools, for example, findings are repeatable and can be arrived at objectively. However, when conducting a security code review, findings are not necessarily repeatable and are not always identified in an objective manner. For example, a security code reviewer may be more skilled at finding vulnerabilities in one programming language versus other, or they may be more proficient with a particular type of vulnerability than others. Factors like these will affect the overall quality and sufficiency of the security code review process. As a final note regarding the advantages and disadvantages of security code reviews, security code reviews, like any other method for identifying risk in applications, is not a silver bullet. Security code reviews can help you find many security vulnerabilities, but not all possible vulnerabilities. It should never be used as a replacement for other security assessment methods, but rather in conjunction with other methods. Several of the disadvantages of security code review process discussed in the previous slide can be addressed by the following security code review tips. The first tip is to use a multi-pass approach. Many code reviewers make the mistake of trying to conduct a security code review using a single pass. Certainly, security code reviews can be performed in this manner. However, with larger applications, doing so may prove to be very difficult. Fatigue tends to set in after processing large segments of code, which often increases the chances of errors being introduced into the security code review process. As the name suggests, with a multi-pass approach, application code implementations are reviewed multiple times. Each pass could have a specific objective, such as looking for a particular type of vulnerability. Since reviewers are looking for specific vulnerabilities such as buffer overflows, SQL injection, and cross-site scripting, rather than all vulnerabilities, each pass can be conducted more quickly and the likelihood of reviewers suffering from fatigue can be reduced. Furthermore, each pass can also be performed by different reviewers to reduce the likelihood of human error. The second tip is to focus security code review efforts on high priority code, and then focus security code review efforts on less critical code as time permits. Since security code reviews can become very expensive, prioritizing security code review efforts is an important way to help ensure that critical components have been thoroughly reviewed prior to customer release, while staying within available budgets. Further discussion regarding prioritizing application code will be discussed later in this presentation. One common criticism about the security code review process is that it is often performed in an ad hoc manner. With the ad hoc approach, reviewers take an application and begin randomly looking for vulnerabilities without any clear objectives. Certainly, security code reviews can be performed in this manner. However, in the absence of documented goals, it is difficult for application development teams to understand the level of coverage that is provided by security code reviews. Many questions begin to surface, such as, which vulnerabilities have been considered when conducting the security code review? To what extent were the vulnerabilities tested? Specifically, which vulnerabilities were not investigated when conducting the security code review? All these questions are difficult to answer when security code reviews are performed in an ad hoc fashion. By first establishing clear security code review objectives, and then manually reviewing code against those objectives, application developers can gain more accurate understanding of the security posture of their application. Application teams can then bring in other security assessment methods, such as code analysis tools, to address other objectives not evaluated by security code review efforts. Example security code review objectives may be to ensure the following: that application code does not ignore return values, that all pointers are checked for validity, and that all untrusted data is validated prior to use. As previously mentioned, security code reviews are not meant to replace other security assessment activities and should be used as a complementary activity. Code reviews by themselves can be an effective means to identifying security vulnerabilities in code. However, the benefits of security code reviews are amplified when they are done in the context of other security assessment activities. In fact, when security code reviews are performed in conjunction with other assessment activities, the complexity of performing security code reviews can be greatly decreased, therefore reducing the total expense associated with conducting the security code review process. For instance, using automated code analysis tools as recommended by the Microsoft SDL could be performed prior to expending manual review efforts. Using automated code analysis tools introduce the benefit by providing a higher degree of code review coverage. Code analysis tools can also help identify more common and frequently encountered vulnerabilities called low-hanging fruit. Reviewers can then allocate their efforts to address more critical components of the application and to identify more complex and less apparent vulnerabilities. Automated code analysis tools may also provide early indications as to the types of vulnerabilities that are most prevalent in the application code. Security code reviewers can use data from code analysis tools to better define security code review objectives and more effectively focus their efforts during the review process. Another example might be to create threat models prior to using code analysis tools and performing security code reviews. Threat models are used to decompose an application and can help developers, testers, and security analysts to better understand the internals of an application. Threat models also expose critical areas of an application that are most prone to attack. Security code reviews could take that knowledge and focus their efforts on high-risk components of the application and expend less effort on components with minimal risk. Security training materials could be updated to address the types of vulnerabilities encountered through employing a security code review process. This would help better ensure that developers do not introduce the same vulnerabilities into future code. Finally, the lessons learned from performing security code reviews, such as the types of vulnerabilities that are most prevalent for a particular application, could be used to update internal processes. This would help ensure that occurrences of those prevalent vulnerabilities are reduced in future releases of that particular application. Let's now look at some examples of how to review application code for some of today's most common security vulnerabilities, including buffer overflows, SQL injection, and cross-site scripting. The examples presented in the following slide represent common ways by which these types of vulnerabilities manifest in code and is not meant to be an all-encompassing guide. Presentation materials that discuss each of these vulnerabilities in more detail are available and should be reviewed accordingly if you have not already reviewed their contents. Buffer overflows can manifest in a myriad of different ways. Unsafe function calls and unsafe custom code that writes into buffers are some of the common ways that buffer overflows can be present in code. Does this mean that security code reviewers need to know all the possible ways that buffer overflows can be created? Fortunately, the answer is a resounding no. All buffer overflows, regardless of the technology or platform being used, manifest whenever an application attempts to write data into a fixed-length buffer beyond the bounds of that buffer. By looking for this pattern in code, security code reviewers can more easily find buffer overflows in any platform or technology. Here is some sample C code that implements a function called copyBuffer. This function reads a character pointer and allocates a fixed-length 32-byte buffer called buffer. CopyBuffer then copies the source argument into buffer using a call to stir ncopy and restricts the size of that copy to 32 bytes. Finally, copyBuffer null terminates buffer by inserting a null terminating character at the last index of buffer. Can you see what's wrong with this code? If the problem is not immediately apparent to you, try applying the pattern above to this code. First, do we have a fixed length buffer that will be written into anywhere in this code? Yes, the destination buffer called buffer is one that fits this criteria. Next, will the code ever try to write beyond the boundary of buffer? The answer again is yes, but not with the call to stir ncopy. The overflow occurs when the function tries to null terminate buffer. Take a close look at which element index in buffer gets null terminated. According to the code, the index at size of buffer gets null terminated. The call to size of buffer returns 32. However, buffers in the C and C++ language start at 0 and not at 1. This means that the code is writing a null termination character exactly 1 byte beyond the bounds of the fixed length buffer called buffer. This is what is known as an off by 1 buffer overflow, and it is exploitable. SQL injection is another common vulnerability. SQL injection vulnerabilities are created in code whenever an application tries to execute a SQL query that has been dynamically built using untrusted data. Similar to the buffer overflow discussion, let's apply this pattern to some sample code to uncover a potential SQL injection vulnerability. Here is some sample C# code that defines a method named removeEntry. RemoveEntry accepts two arguments, a string named entryName and a SQL connection object called myConnection. RemoveEntry creates a query to remove a given entry by name and then executes that query using some database server bound to the given SQL connection object. Can you see the potential SQL injection vulnerability in this code? If the problem is not immediately apparent to you, try applying the pattern above to this code. First, is the method building a dynamically built SQL query using untrusted data? Yes, it is. The variable query is dynamically created using the input from the entryName variable. This variable is provided into this function. Therefore, the contents of this variable cannot necessarily be trusted. The second part of the SQL injection pattern is the execution of a dynamically built SQL query. Does this code do that? Yes, it does. Therefore, since the method dynamically creates a SQL query using potentially untrusted data and then tries to execute that query, you know that a SQL injection vulnerability exists in this code. Another common security vulnerability frequently encountered in web-based applications is cross-site scripting. In fact, cross-site scripting vulnerabilities are most common vulnerabilities today. The common pattern among all cross-site scripting vulnerabilities is applications attempting to embed untrusted data in web responses without encoding that data. Here is sample code from